And welcome back to this channel. Dear students, today's topic is reflection by perfect dielectric. It is the topic from the subject electromagnetics, that is EFT for TE and TC students. First we will derive the expression of different parameters for the reflection by perfect dielectric medium, and we will solve the numericals related to this topic. I have drawn a simple diagram. This vertical line represents boundary between two media. This is medium 1 and second is medium 2. I have written different symbols like epsilon 1, mu 1, eta 1, same as epsilon 2, mu 2, eta 2. Recall the things. Epsilon is permittivity, mu is permeability, eta is intrinsic impedance. Suffix 1 represents, these are the notations, values for medium 1, similarly for medium 2. Now, very important part is that the analogy is similar to the analogy of light rays. EI stands for, basically E stands for electric field. We will be talking about two terms. One is E, that is electric field, and another is H, that is magnetic field. This notation is EI. Suffix I stands for incident. So it is incident electric field. Whenever the wave is incident like this, I am talking about electric field component. There are two components, electric and magnetic field. Part of the wave is getting transmitted into another medium, whereas remaining portion is getting reflected back into the same medium. As I said, the analogy is similar to the transmission and reflection of a light rays. So EI is incident wave, part is getting transmitted into another medium and remaining part is reflected back into the same medium. Observe this, EI and ER are in opposite direction because one is incident wave, another is reflected wave. Now, there is one important parameter that is denoted by eta. Just now I mentioned eta is intrinsic impedance. Basic definition is it is ratio of electric field to the magnetic field. Now, before deriving the things, I will explain you what you are supposed to do. We have to do the calculation for TR and TT. T to the base R represents the reflection coefficient. R stands for reflection. T represents coefficient. T to the base T represents transmission coefficient. Now, reflection coefficient is ratio of ER upon EI in terms of E bar or HR upon HI in terms of H bar. Similarly, transmission coefficient is ratio of ET and EI or HT and HI. So we have to derive these quantities. Now, as I mentioned, eta is ratio of E and H. So keep the thing simple. In medium 1, related to eta, we have eta 1. In medium 2, we have the corresponding value, that is eta 2. So if I am talking about medium 1, then in case of medium 1, I can write eta 1 is equals to EI upon HI. Very simple. What I did, I am talking about medium 1. So eta is E by H. In medium 1, we have incident wave. So EI upon HI. From this, let us say this is equation 1. From this, I can simply write HI is equals to EI upon eta 1. From the same equation, I have written equation of HI. Simply I interchange the position of HI and eta 1. Now, this is the notation, or this is the equation for eta 1. Same thing I can write for eta 2. Eta 2 is in the second medium. Stick to the basic formula. It is E by H. In the second medium, we have ET. This I have written the notation in terms of E bar. Similar notations are applicable in terms of H bar. So for eta 2, as I have showed in this diagram, the value of ET, there may be value of, or there is value of HT. So for eta 2, I can write ET upon HT by considering basic definition E by H. So say this is equation 2, and from this I can well write HT is equals to ET upon eta 2. So these are the two basic equations which I have generated from this equation. Now, do remember EI and ER are in opposite direction, to each other. So I can well write one more equation. ER is equals to minus eta 1 HR. How I have written this equation? See, eta is E by H. First equation I have written in terms of I, that is incident wave. Second in terms of transmitted wave. Now if I will talk in terms of reflected wave, then basic formula is E by H, or E is equals to eta into H. So ER is equals to minus eta 1 into HR. Why? Because ER is in opposite direction to that of EI. Now from this equation 3, I can well write HR is equals to ER upon minus ER upon eta 1. Simple way, I have transferred this minus eta 1 to the LHS, so I got equation of HR. Now we need to apply the boundary conditions. How to do it? Make the thing simple. While applying boundary conditions, you don't have to memorize all the boundary conditions which we have studied earlier. Whatever components are there in medium 1, take the addition of those components equals to components in medium 2 without considering the directions, without considering the signs. For example, in terms of E, in medium 1, I have EI and ER. So I will write it as EI plus ER. As I said, don't consider directions, don't consider the signs. So it is simply EI plus ER. Addition of components in medium 1 is equals to components in medium 2, that is ET. This is the equation of boundary condition which I have written in terms of E. Same equation I can write in terms of H as HI plus HR is equals to HT. Say equation number 5. Now what I am supposed to do, in equation 5, put the value of HI and HR. This we have already discussed. HI is EI upon eta 1. HR is minus ER upon eta 1. Keep HT as it is. So I will get the new equation, EI upon eta 1 minus ER upon eta 1. I am taking the value of HR, this value minus ER upon eta 1 is equals to, I am putting the values in equation 5, is equals to HT. Say it is equation 6. What I am trying to do, I want to derive the expression ER upon EI first. So I am eliminating ET term. This is one equation of HT. I am supposed to do one more equation of HT. How to do it? We have already used equation number 4, equation number 5. Now make use of equation 4 to express the value in terms of HT. But in equation 4, at the RHS, we have term ET. Now refer this equation. We have HT is ET upon eta 2. From this equation, I can write ET is equals to eta 2 into HT. So put this value in place of ET in equation number 4. So I am putting this value in place of ET in equation number 4. LHS remains as it is, that is LHS of equation 4 is EI plus ER. It remains as it is equals to, what I said, in place of ET, put the value eta 2 into HT. So it becomes eta 2 into HT. Therefore, I can write it like this, EI upon eta 2 plus ER upon eta 2 is equals to HT. Very simple. I have transferred this eta 2 at the LHS, so it will get divided to both the terms. So this is equation number 7. Now both equations 6 and 7 are for the same thing, HT. So we can equate equation 6 and 7 because both equations are same. They are equal to HT. So I am equating these two equations. So if you equate these two equations, you will be getting the condition EI upon eta 1 minus ER upon eta 1 is equals to EI upon eta 2 plus ER upon eta 2. What I did, I have eliminated the term ET first. I have eliminated term ET first. Then I have replaced HT by corresponding values. So I got equation in terms of EI and ER. Now to simplify the equation, take 1 by eta 1 common from the LHS. So I will get EI minus ER. Similarly, take 1 by eta 2 common. This eta 2 is common term for the denominator at the RHS. So you will be getting EI plus ER. Now just interchange the things, transfer this eta 2 at LHS, transfer eta 1 at RHS. So I will write it like this, eta 2, I have transferred eta 2 at the LHS in the bracket EI minus ER is equals to eta 1, I have transferred eta 1 at the RHS in the bracket EI plus ER. So this gives me eta 2 EI minus eta 2 ER is equals to eta 1 EI plus eta 1 ER. What I am supposed to do? I am supposed to calculate this value TR, which is ratio of ER upon EI. So to get this ratio ER upon EI, transfer all ER terms at one side and EI terms at another side. So I will be doing it like this. This term is already in terms of ER, so I am keeping second term as it is. Then related to this ER, I have this last term, transfer it at the LHS, it becomes minus eta 1 ER is equals to. This term is in terms of EI, I am keeping it as it is. This term, I will transfer it at the RHS, so it becomes minus eta 2 EI. What is my aim? We want ratio ER upon EI, so take ER common from this. So you will be getting minus eta 2 minus eta 1 is equals to, take EI common from the RHS, so EI in the bracket eta 1 minus eta 2. Therefore, I can write TR, this formula, which is ER upon EI, which is equals to, I want ratio ER upon EI, so I transferred EI at the LHS. So transfer this term at the RHS, so it becomes eta 1 minus eta 2 upon minus eta 2 minus eta 1. To make the thing simple, multiply numerator and denominator by minus 1. So last equation can be written as TR is ER upon EI is equals to, what I said, multiply numerator and denominator by minus 1. This term will be minus, this term will be plus. I will write plus term first. So it is eta 2 minus eta 1 upon eta 2 plus eta 1. I have multiplied both numerator and denominator by minus 1. I got this equation, eta 2 minus eta 1 upon eta 2 plus eta 1. Now remaining part is pretty simple. Once you will reach up to this position, remaining calculations are easy. Second parameter, what I need, I want the transmission coefficient in terms of E bar. So it is given as ET upon EI. So first I will write this formula, TT is equals to ET upon EI. Just now we discussed ET is equals to EI plus ER. So put this value, ET is EI plus ER upon EI. So this gives, divide each term by EI, so it becomes 1 plus ER upon EI. We have the ratio of ER upon EI, put this value, so you are getting TT, which is equation of ET upon EI. I am writing basic formula, which is equals to 1 plus, I am putting this value, eta 2 minus eta 1 upon eta 2 plus eta 1. So it is eta 2 minus eta 1 upon eta 2 plus eta 1. Just simplify this equation, take LCM, so you get eta 2 plus eta 1. I have multiplied this term with 1 plus eta 2 minus eta 1 upon eta 2 plus eta 1. So final equation for transmission coefficient in terms of E bar can be written as, this plus and minus eta 1 gets cancelled, so it is 2 eta 2 upon eta 2 plus eta 1. This is the equation of transmission coefficient in terms of E bar. Now, same way, whatever I did it for TR and TT, that is reflection and transmission coefficient in terms of E bar, I have to obtain similar expression in terms of H bar. Very simple, you don't have to do any extra calculations. So, for in terms of H bar, I can write TR, I will use this formula, is HR upon HI. Just now we have written the equations of HR and HI in terms of E. So we have HR is equals to minus ER upon eta 1 and HI is equals to EI upon eta 1. Just now we have discussed, we have developed this equation. So put these values. So I will get the another equation like this. So TR, which is basic equation, is HR upon HI, which is equals to minus ER upon eta 1 divided by EI upon eta 1. Both sides denominator is eta 1, so gets cancelled. So simply it is minus ER upon eta 1. Now we have already derived this formula, ER upon eta 1, ER upon EI, this is ER upon EI, eta 1 gets cancelled. We have already derived this formula, ER upon EI. So put this value, this minus sign is as it is. This formula is eta 2 minus eta 1 upon eta 2 plus eta 1. So final equation is TR in terms of H bar is HR upon HI. This, if you absorb this minus sign in the numerator, first term becomes negative, second becomes positive. So it is eta 1 minus eta 2. Positive term I am writing first, then minus eta 2 divided by eta 2 plus eta 1. This is the formula of reflection coefficient in terms of H bar. Now remaining part, I want to derive expression of transmission coefficient in terms of H bar. Again, very similar to the earlier part. This transmission coefficient in terms of H bar can be written as HT upon HI. Similar to the earlier part, HT is HI plus HR upon HI. So it is simply written as 1 plus HR upon HI. We already derived this formula HR upon HI. Put this value, so it becomes 1 plus eta 1 minus eta 2 upon eta 2 plus eta 1. Take the LCM, it becomes eta 2 plus eta 1 plus eta 1 minus eta 2 upon eta 2 plus eta 1. So last step, this plus and minus eta 2 gets cancelled. Therefore final equation for TT in terms of H bar is HT upon HI, which is equals to 2 eta 1 upon eta 2 plus eta 1. So these are the derivations of all components related to reflection coefficients. Now we will solve few numericals to get an idea how to make use of this formula. The given question is given intrinsic impedance eta 1 is 100 ohm, eta 2 is 300 ohm. The normal incident electric field value of EI is given 100 millivolt per meter. Find reflection and transmission coefficients and reflected and transmitted H bar. Now, reflection and transmission coefficient means value of TR and TT in terms of E bar, because given is the equation in terms of E bar, and reflected and transmitted H bar means value of HR and value of HT. Now, first part, I have this formula TR. So TR is given as ER upon EI, which is same as eta 2 minus eta 1 upon eta 2 plus eta 1. Simply put the values. So it is 300, eta 2 is 300 minus eta 1 is 100 divided by 300 plus 100. This value will be 0.5. Do remember it is ratio of two impedances, so it is unitless quantity. Now from this I can well write, see, this is basically equation for TR, or in another language value of ER upon EI. From this I can write ER is equals to 0.5 times EI. What I did, I have transferred EI at the RHS, so which is same as 0.5 into 100 millivolt per meter. I haven't converted millivolt into volt, I have kept it as it is. Now in the first part I need to also calculate transmission coefficient. Refer the second formula, it is ET upon EI, which is equals to 2 eta 2 upon eta 1 plus eta 2. Again put the values, so it is 2 into 300 divided by 100 eta 1 plus 300 eta 2. So this answer is 1.5. From this I can well write ET is equals to, I am making use of this notation, ET upon EI is 1.5. So ET is equals to EI into 1.5, which is same as 1.5 into value of EI, which is given in the question, that is 100 millivolt per meter. This is the calculation of first part. Now second part. For the second part, I need to calculate reflected and transmitted H bar, that means HR and HT. So I have the ready-made formula. HR is equals to minus ER upon eta 1. So it is HR is minus ER upon eta 1. So I will put the value of ER, which I have already calculated in the first part, minus 0.5 into 100. Do remember this is in terms of millivolt per meter, upon value of eta 1. Eta 1 is 100. So it is minus 0.5. What about unit? Basic unit of H is ampere per meter, but it is in terms of milli. So I will write it as milliampere per meter. Now next equation of HT, I have this formula ET upon eta 2. So it is ET upon eta 2. ET I have already expressed in terms of EI. So I have this value 1.5 into 100 upon eta 2. Value of eta 2 is 300. So I will get 0.5 again milliampere per meter, because I haven't converted any millivolt or milliampere, whatever, in terms of basic unit. So this is the final answer of HT. Now next type of variation in such numericals is determine amplitudes of reflected and transmitted fields if EI is given like the last question in region 1, for which epsilon or mu or 1 is given, sigma is given. Sigma is conductivity. As such, conductivity is not required in such numericals. And region 2 is free space. Do remember, region 2 is free space and intrinsic impedance of free space, that is eta 2, because it is given as region 2, is 377 ohm. This is the fixed value. But for region 1, the value of eta is different. I need to calculate this value of eta, that is eta 1. Basic formula is mu 0 mu r upon epsilon 0 epsilon r. Naturally I am doing it for medium 1, so it is mu 0 mu r 1 upon epsilon 0 epsilon 1. Simply put the values. Value of mu 0 is 4 pi into 10 raised to minus 7 into mu r 1 is given in the question into 1 divided by epsilon 0 is 8.854 into 10 raised to minus 12 into epsilon r1 is 8.5. It is again given in the question. If you solve this on the calculator, value of eta 1 will be 129.22. Its unit is ohm because it is intrinsic impedance. This is the only difference as far as first numerical and this numerical are concerned. Remaining part is very much similar to the earlier numerical. Next, what I need to do, first I will calculate the ratio TR. TR is, we know the formula, ER upon EI, which is eta 2 minus eta 1 upon eta 2 plus eta 1. Same formula what we used right now. Put the values. It is 129.22 minus value of eta 2 is 377 ohm. So it is 377 minus 129.22 upon 377 plus 129.22. Again, if you solve this on the calculator, this value will be 0.4895. This is the value of TR. But from this you can calculate ER, because EI is given in the question. EI is given as EI is given as 1.5 millivolt per meter. So from this I can write ER is equals to EI, I will transfer EI to this side, into 0.4895. Put the value of EI, that is 1.5, into this value. So answer of ER will be 0.7342 millivolt per meter. This is the reflected field in terms of E bar, which is asked in the question. Next, I need to calculate the value of ET. How to do the calculation? We have this formula, TT is ET upon EI. Directly I will write this formula as ET upon EI is equals to 2 eta 2 upon eta 1 plus eta 2. Therefore, ET is equals to EI, I will transfer EI to this side, in the bracket 2 eta 2 upon eta 1 plus eta 2. Simply put the values like the previous case. EI is 1.5 millivolt per meter. Put the value of eta 2. Eta 2 is 377. Eta 1 is 129.22. And simplify it on the calculator. This answer will be 2.2234 again millivolt per meter. This is transmitted electric field. Now, to calculate H bar, I mean HR, I have to make use of this formula. HR is equals to minus ER upon eta 1. We have the value of ER, put the values 0.7342 upon, this minus sign is of course there, upon eta 1, that is 129.22. If you solve this, this answer will be minus 5.6818. Last part, I need to calculate ET. Direct formula we have HT is equals to ET upon eta 2. Again same way, we have the value of ET, put this value, then eta 2 is 377 ohm. So if you put these values, you will get the answer that is equals to 5.9262. This answer will be into 10 raised to minus 6. So I will write it as microampere per meter after putting this value and after solving it on the calculator. So dear students, these are the two possible types of variations as far as the reflection part is concerned. So that's it for today's session. Thanks for attending this video. Thank you very much.